Hi and welcome to this 5th year higher level maths revision video. In this video we're going to work through worksheet 5 from 2021 and it's a coordinate geometry worksheet. Question 1 is a coordinate geometry of the line question and it's worth 25 marks.
So question 1, it says 2 points P, which is -4, -7 and Q, 1, 3 lie on opposite sides of this particular line. Calculate the ratio of shortest distance from P and Q to the line L. So when we see shortest distance, we need to think of our perpendicular distance formula. So that's really important. So your perpendicular distance formula is going to be on page 19. Of your log tables. So at the very top of page 19 you'll find your shortest distance formula, and that's what we're going to use. So if we take a look at this diagram here, now just bear with me because I haven't got a ruler on this, but we're basically trying to calculate this distance here, this perpendicular distance, and this perpendicular distance here. Okay, so the first thing we're going to do is P to L. Okay, so we have -4, -7, which is x1, y1. And we have 2x plus y plus 7 equals 0, which A equals 2, B equals 1, and C equals 7. And the formula we're looking at, the distance is equal to ax1 plus by1 plus c all over the square root of a squared plus b squared. So subbing into our formula here, we get 2 times -4 plus 1 times -7 plus 7, square root of 2 squared plus 1 squared. And working that out, we get 8 over root 5. If you're putting that into your calculator, it will probably simplify it down, say root 5 over 5. Both are the same. So then the second one we want is Q to L. Same formula, but this time we have Q, which is 1, 3, and that's our x1, y1. Our line is still the same, 2x plus y plus 7 equals 0. Again, A is 2, B is 1, and C is 7. Our distance then here is 2 times 1 plus 1 times 3 plus 7 all over the square of 2 squared plus 1 squared. And that will work out for you as 12 over root 5, but again, if you're using your calculator, it doesn't like having our side on the bottom, so it might change it to 12 root 5 over 5. So they want the ratio of the shortest distance from P to Q to the line L. So basically we want 8 over root 5 is to 12 over root 5, which simplifies down. 8 is to 12, divide both sides by 4, or 2 is to 3. So that's our final ratio. This is a really good example where leaving it in third form makes the question and I suppose your answer a lot easier than if you were to try use decimals or rounding it in some way. If you use decimals, you might get this really nice cancellation that happens here at the end. So oftentimes it's in your interest to work with fractions and thirds rather than changing things into decimals. So then it said calculate the ratio of the distances from P to Q along the line L. Calculate the ratio of the distance from P to Q to the line L along the line PQ. So this time we have a diagonal line that's going from Q to P. So we want to find the distance from Q to the line and from P to that line. So first thing we need to do is we need to find the equation of PQ, because that's what we're using. We're splitting PQ into two pieces, and that's what we're looking at. The PQ is going to be set from Q to the line L and from P to the line L. So to get the equation, we need the slope. So the slope of PQ, we need to work with our 2 points, P, which is minus 4, 7, and Q, which is 1, 3. This is our x1, y1, x2, y2. Our slope formula, y2 is page 18 minus y1, or x2 minus x1. So we get 3 plus 7 minus minus, and 1 plus 4, and that simplifies to 10 over 5, which is 2. So then to actually get the equation, we have y minus y1 is equal to m bracket x minus x1. So again, this is coming from page 18. So we have y plus 7, I'm going to use our y1 from above, 2 times x plus 4, we get y plus 7 is equal to 2x plus 8. So y is equal to 2x plus 1. So the next thing we want to find out is the point of intersection. So effectively what we have, and I'm going to just sketch here just so we can see. You do have a picture, and it's just unfortunate I haven't brought the picture here. But we basically have a line that's going like this. We have a point here and we have a point here. So what we're trying to do is figure out, well, look, if we have this line here, so this is P and this is Q. What is the distance from Q to this point here and from P to this point here? And that purple point here is the point of intersection. So really, the only reason we wanted to find the equation is to help us get the point of intersection. So we now have, this is PQ. Now I'm going to rearrange this slightly, so 2x minus y plus 1 equals 0, because we're going to have two equations. We have the first one, which we were given, plus y plus 7 equals 0, and that's this line here, line L. The second one is then the one we just worked out, minus y plus 1 equals 0. So to get the point of intersection, we're going to do simultaneous equation. Notice here how those y's cancel straight off. So we get 4x plus 8 equals 0. So we get 4x equals minus 8, x is equal to minus 2. And then we want to sub that back in. So we go to 1 and we get 2 times minus 2 plus y plus 7 equals 0. So we get minus 4 plus y plus 7 equals 0. So y plus 3 equals 0. So y is equal to minus 3. So that point is minus 2 minus 3. So now that we have that midpoint, we're going to calculate the distance from Q, which is 1, 3, to the midpoint, which is minus 2, minus 3. And we're going to do that just using our distance formula. So let's label them first. x1, y1, x2, y2. I'll do a little arrow here so we know that it's distance. Okay, so it's x2 minus x1 squared plus y2 minus y1 squared. So for this, minus 2 minus 1 squared plus minus 3 squared. And what we end up with here is 3 root 5. So that's the point Q. So then we can do the point P, same idea. Minus 4 minus 7, which goes to the point minus 2 minus 3. I'm going to work that out. So again, we'll label x1, y1, x2, y2, square root of x2 minus x1 squared plus y2 minus y1 squared, and when you work that out you get 2 root 5. So the ratio of the distance P to Q along the lines PQ, so we get 2 root 5, so that's P is to 3 root 5, and simplifying that down you get 2 is to 3. So then Tim, what conclusion can you draw from your answers in part A and part B above? Explain your answer with reference to a geometric theorem on your course. So A, we found that the ratio was 2 is to 3 in its simplest form, and in B we found that it was 2 is to 3 in its simplest form. So let's actually take a look at the diagram here. So first of all we worked out this, and that was the perpendicular distance, which meant that this was a right angle here. We then looked at P is to Q like this, and we had a point here. So we know that the ratio of those blue lines are the same as the ratio of the red lines. Okay, so what we can say about these two triangles is that these two triangles are similar triangles. So how we could explain that is, so the two sides of the triangles are in the same ratio. So this blue line is this line here, the blue line from Q, and the blue line from P, it's 2 is to 3. Similarly with the red line, it's 2 is to 3. Given that they are the same ratio, we can conclude that the triangles are similar. So let's write something down for this. So given that two sides of the triangles are in the same ratio, the triangles are similar triangles. Okay, and this is the converse of theorem 13, which has got to do with similar triangles. So theorem 13 works in two ways. The first is that if you have similar triangles, that the sides are in a given ratio. The other way works if they're in a given ratio, they are similar triangles. So that's the word converse. It works in the opposite way. So nothing terribly difficult there, but it was hard to kind of see this without drawing it out, and especially that link to something in the geometry course as well, but it's really good to see and to understand all those links.
Question 2 is a coordinate geometry, the line question, and worth 25 marks.
So let's take a look at question 2 then. So it tells us OPQR is a parallelogram where O is origin 0, 0, and the coordinates of P are K0 and the coordinates of Q are 4, 2. They also tell us that OR lies on the line y is equal to 2x. Now, it's important, there's a few little bits of information here that you have to look beyond what we're told. So the first is that the point OR lies on the line y is equal to 2x. Note that that has no constant, so it must cross the x-axis or the y-axis or both axes at 0, 0. So basically, because y is equal to 2x, when x is 0, y is also 0. So it passes through the point 0, 0, and that's really important, and I'll explain why in a second. So this line passes through 0, 0. Okay, so OPQR is a parallelogram, so we're basically trying to figure out the value of k. So the only other thing that we know is we don't really have enough information. If we had 3 points, we could work with distances and things like that, but we don't. However, with a parallelogram, like the name suggests, that the sides are parallel. So based on a parallelogram, if you just randomly draw the points as they're given, so say this is O, P, or Q. Now that's a very simplistic one. Sorry, O, P, and then Q should be up here because they're named in order. Q, or. So by that logic, O, or must be parallel to P, Q. And that's what we're going to say, because O, or, the slope of O, or is based on that line. So the slope of O, or is equal to 2. And we're taking that straight from here. So M is equal to 2. That's coming straight from here. And we know that that's parallel to the slope of PQ. Now for PQ we have 2 points, K0, which is for P, and Q, which is for 2. So this is x1, y1, x2, y2, and the slope formula, which is on page 18, is y2 minus y1 over x2 minus x1. So that's 2 minus 0, 4 minus k. So that's 2 over 4 minus k. So we know that those two slopes should be equal. So therefore, 2 over 4 minus k must equal 2, since O, or is parallel to PQ. And rearranging this, end up with 2 is equal to 8 minus 2k, 2k equals 6, k equals 3. So using that idea of parallel lines. Now, it was probably a little bit difficult given the way that they presented that or being on that line and the idea of the slope of O, or. But having covered the idea of no constant means it passes through the origin, you need to be aware, you need to be on the lookout for things like this that will help you. So the next part asks us for the coordinates of or. So we now know basically 3 of the points. We have the origin here, which is 0, 0. We have the point P here, which instead of K0 we can now say is 3, 0. Q is 4, 2, and or is some x, y. Now we can have the idea of a translation, and we can see it here. So if I go from P, 3, 0 to Q, what is my rule that I do that? So for that, I'm adding 1 to the x part and I'm adding 2 to the y part. By that same logic, I can go from the origin 0, 0, use the same translation and end up at 1, 2, which is or. Now you can use the idea of distance and slope, but it becomes too complicated. So we're just using that idea of a translation. So translating or moving from P to Q is the same as translating or moving from O to or. It is using the distance, but just in a simplistic way. So it then says, hence find the area of the parallelogram OPQR. Now, the base by the perpendicular height is how we would work out the area of a parallelogram using traditional methods. However, remember that sometimes there may be an easier way given we're not working in the traditional just lengths, we're working in coordinates. So if you take a look, one of our points is 0, 0. And that's useful for us because if I have my parallelogram like this, I have a triangle, and I have a triangle where one of my points is 0, 0. So if I work out the area of the triangle OPR, I can then multiply it by 2 because this triangle over this side will be the same. So I can use my formula here, which is a half. Now let's get all these set up. So my origin is 0, 0, I don't need that. P is 3, 0, and R is 1, 2. So half of x1, y2, x2, y1. So that's a half. X1, y1, x2, y2. Half of 3 times 2 minus 1 times 0, half 6, which is 3, but then multiplying it by 2 gives me 6 units squared. Okay, so that's my area here of OPR. Now it worked the same if you went OPQ, but you would need to include that O unless you wanted to do a translation, then becomes more difficult. The other option would be to use the idea of the perpendicular height. So from a point to a line, we do have the equation of the line, so we could do from P, the distance from P to R, so we could use that formula, but it's just a little bit more complicated. The easiest way is to look and use the triangle formula and double. So part B, the line OS has a positive slope and intersects the line PQ at S such that the angle OSP, so the angle at S, is equal to 45 degrees. Find the coordinates of S. So first thing we need to do is we need to look and see, well, how are we going to figure out the angle between two lines? And we can do that using the formula which is in your log tables on page 19. And it's the tan of theta is equal to plus or minus the slope 1 minus slope 2 all over 1 plus slope 1 by slope 2. So it's at the top of page 19. It's the angle between two lines of slope M1 and M2. So that's the formula we're going to work with. So the two lines we're talking about here is we have the line OS and the line PQ. Now, given that we don't know what S is and the question is asking us to find the coordinates of S, we can say M1 as the slope of OS, and we're just going to let that equal M. We don't know what it is, we'll just let the letter M stand for that. So M2 is equal to the slope of PQ. Now, back in part A and part I of that, when we were finding the value of K, we actually worked with the slope of PQ, and we said the slope of PQ was the same as the slope of OR, which was equal to 2. So you don't need to go work that out again. We have that information earlier on in the question. So now, working with this formula here, we have the tan of theta is equal to plus or minus M1, which we're going to have M minus 2, 1 plus M by 2. Now, we've been told that the angle is 45 degrees. So the tan of 45 degrees equals plus or minus M minus 2, 1 plus 2M. And in the log tables or using your calculator, whichever way you want to do it, we can work out that the tan of 45 degrees is 1. Plus or minus M minus 2, 1 plus 2M. Now, there's a plus and minus here, so we have two options. So we have where we could take the positive. If we take the positive option, what we end up with is 1 plus 2M is equal to M minus 2. Working through that, we get M is equal to minus 3. Now, that is not correct because we have been told that it has a positive slope. So the positive way, the working with that positive sign in that formula is not going to work. So if we instead then work with the negative sign, we get 1 plus 2M is equal to minus m minus 2. Notice I'm using the bracket here, and that's to make sure that all the signs are changed correctly. If you don't use the bracket, there is a chance you might just change the sign on the m and not the minus 2. You leave that as a minus 2 instead of change it to a plus 2. And that obviously will give us the wrong answer. So we have 2 minus 1, which is 1. So m is equal to a third, which is our positive answer, which is our positive slope. So that is, we've worked out our slope. And it's our slope of OS, m. Now, that wasn't what they wanted. They wanted us to find the coordinates of S. Now, although we know the slope, the coordinate of S itself, we know, well, we'll have to say S is equal to x, y. So we don't know the x or the y coordinate. Because of that, we can't just straight away use our slope, because that will leave us with two unknowns. There's a series of points along the line OS that will give us that slope, so we wouldn't be able to pinpoint a specific S. In order to do that, we're going to have to work out first the equation of OS. So that should be straightforward to do now that we have the slope of OS and we have a point, so 0, 0. So when we do that, using our formula from page 18, y minus y1 is equal to m bracket x minus x1. We get y minus 0 is equal to 1/3 x minus 0. So we're left with 3y is equal to x, or if you prefer, x minus 3y equals 0. So that's our OS. Now, they did tell us one other thing about that coordinate S, and it intersects the line PQ at S. So S is that point of intersection. So it's the point of intersection of OS and PQ. So we're going to find now the equation of PQ. So for PQ, you have a few different options. So we're going to use the point 30, which is P, and its slope, which is 2. And when we work that out, get y minus 0 is equal to 2 bracket x minus 3. Y is equal to 2x minus 6. And again, if you prefer to rearrange it, that's fine. So this here is our equation 1, and this is our equation 2. And we're going to get the point of intersection by working with equation 1 and equation 2. So equation 1, x minus 3y equals 0. This is 2x minus y is equal to 6. So we're going to multiply the top line by minus 2 to get that to cancel. So we get minus 2x plus 6y equals 0. Gives us 2x plus y equals 6. These cancel. We have 7y equals 6. Sorry, apologies. I have correct sign there. It should be a minus y, and that leaves us with 5y equals 6. So y is equal to 6 over 5, or if you're putting in decimal, 1.2. So then to figure out what the x coordinate is, we can go back to equation 1 just because it's a little bit simpler. And we have x minus 3 times 6 over 5 is equal to 0. So x is equal to 18 over 5, or 3.6. So the coordinate here, 18 over 5, 6 over 5. That is the coordinate of S. So there's a lot to that question there. It wasn't just one little piece. There was quite a lot, and we see that with coordinate geometry of the line questions. Often you can have to do a series of little pieces. Now, using that formula of the tan of theta shouldn't have been too bad. Getting the equation of a line has come from junior cert. It's simultaneous equations, junior cert. So like none of the maths in that is quite difficult. It's just about bringing it all together and knowing that that was what you needed to do.
Question 3 is a coordinate geometry of the circle question and is worth 25 marks.
So our first question. The circle S, which is x squared plus y squared plus 2gx plus 2fy plus c equals 0, touches the y-axis at the point A, which is 0, 2. So this point here, and I'm going to write in beside it, is 0, minus 2. Write down the value of f and hence show that c is equal to 4. So the first thing I'm going to do is I'm going to put my center point into this circle. And that center point is given as minus g minus f. Now, because of the way that this y-axis is a tangent to the circle, we can draw a line from the center to A, and it will be at right angles to this tangent. That means that our center point, we're going to be able to use the y value of A to get the y value of our center point. So straight away, we know minus f is going to be minus 2, therefore f equals 2. So straight away from our little picture here on the right, we can pull out f equals 2. So then it says, hence show that c equals 4. So we're going to work with the point A, which is 0, minus 2. And we're going to sub into our equation of the circle. We know that that point is on the circle, so when I sub in, the equation should be balanced. 0 squared plus minus 2 squared plus 2g times 0 plus 2f, which is now 2 times minus 2, plus c equals 0. Anything with a 0 disappears. We get 4 minus 8 plus c equals 0. We get minus 4 plus c equals 0. Therefore c equals 4, which is exactly what they asked us to do. So part B. The center of S lies in the third quadrant, and S makes a chord of length 4 root 3 on the x-axis. Find the value of g, and hence write down the equation of S. So we now know that these 2 points here create a chord of length 4 root 3. Now my center point is here. One of our circle theorems states that when I draw a radius perpendicularly through a chord, it bisects it, which means it cuts it in half. So I now have 2 root 3 and 2 root 3. I have a little right angle triangle here, and I also know the height of this triangle because remember that point, this point A? This was given as 0, minus 2. So this height here will be equal to 2. So what we actually have is a right angle triangle with 2 root 3 here and 2, and we're going to work out the length of the radius. So we're going to use Pythagoras. So when we use Pythagoras, C is always the hypotenuse. On the other two sides, it doesn't matter which one is A and which one is B. So C squared equals A squared plus B squared. C squared is equal to 2 squared plus 2 root 3 squared. C squared is equal to 4 plus 12, so 4 times 3. So C squared is equal to 16, so C is equal to 4. So that is my radius. So my radius equals 4. So what we can do at this point is we can go to our page 19 in our log tables, and we know a lot of information. We can work through it there. However, if we go back to our actual diagram, we can see, because we have the y-axis as a tangent, we know that the distance from the y-axis to the center point is going to be r. So I'm going to show that on the diagram here in red. So that there is r. So that actually tells me where on the x-axis that center point will lie. So here we've got minus g will be minus f. Sorry, minus g will be minus 4 because it is on the negative sense of the x-axis. Therefore, g equals 4. So now I can go and write the equation of the circle. So they gave us the general equation. If they didn't give us the general equation, we can find it on page 19 of our log tables. Plus 2gx plus 2fy plus c equals 0. Instead of using this one, we would be better off, because we know g, f and the radius, we would actually be better off to work with the one that's given as x minus h squared plus y minus k squared equals r squared, given that is the center. So my center point here is minus g minus f, it's minus 4 minus 2, so that is actually hk. So we get x minus 4, so that's plus 4 squared, plus y minus 2, so plus 2 squared equals 4 squared, and you can multiply that out then if you want. X squared plus 8x plus 16 plus y squared plus 4y plus 4 equals 16. 16's cancel, we get x squared plus y squared plus 8x plus 4y plus 4 equals 0. So we could have worked out our c in other ways, but it was just as easy to work through with our hk formula here. So part C is find the equations of the two tangents from the origin to S. So the first one we actually already know. We know that the y-axis is a tangent. So all we need to do to get that first equation is to write the y-axis as an equation. It is a vertical line, which means that it's a constant, and all of our vertical lines are written as x equals and then the value they go through. So this is going to be x equals 0, and that's the first equation of a tangent that goes from the origin to S. So the second tangent will look something like this. It'll go through our 0, 0, and it will touch the circle. So what we're going to do is we're going to take the point where the tangent touches the circle, and we take the center point, and if we connect these 2 points, we know that that line is perpendicular to our tangent. So to work for the second equation, we're going to work with y minus y1 equals m bracket x minus x1, or you can use y equals mx plus c. Usually we're dealing with this equation. Because we're dealing with the origin, either will work. We have y minus 0, because I know this tangent goes through the point 0, 0. We have m, the slope that we don't know, x minus 0, so the equation is y equals mx. So now what we need to be able to do is figure out that slope, and we'll know the equation. Going back to the radius which we drew from the center to the point where the tangent touches the circle, we know that that distance there should be equal to the radius. We know that the radius is equal to 4. So if we work with this equation, so I'm going to write in the form mx minus y plus 0 equals 0, because we're going to work with the perpendicular distance formula, and it is given as ax plus by plus c equals 0. The point that we're working with is going to be our center point, so we worked that through before. It's minus g minus f, so from earlier in the question that was minus 4 minus 2. That's x1, y1. Our formula is given on the very top of page 19, and it is a x1 plus b y1 plus c, and that's all in absolute value lines, all over the square root of m squared plus minus 1 squared, and that should equal 4. So that should equal the radius. So working with this, we're going to be able to solve for m, and we're going to be able to work out the slope and then in turn the equation. So let's tidy this up a bit. We get minus 4m plus 2, and that should be a 0, all over the square root of m squared plus 1, and that equals 4. I'm going to multiply across by the denominator. Minus 4m plus 2 equals 4 square root of m squared plus 1. So two things that we have here, absolute value signs and a square root. So we're going to get rid of both of them by squaring both sides. There is other ways to deal with the absolute value or modulus signs, but here, because we have the square root as well, we might as well just square it out. So a really common mistake that students make, if I'm squaring out the absolute value signs, I do have to square what's in them. All that the squaring does is make sure that it's positive, so I no longer need them. So we get 16m squared minus 16m plus 4 equals 16, and here the square root and the square cancel, so that's m squared plus 1. So we get 16m squared minus 16m plus 4 equals 16m squared plus 16. 16m squared on both sides cancel, so I have a minus 16m equals 16 minus 4 is 12. M is equal to 12 or minus 16, and that simplifies into minus 3 over 4. So looking at our actual diagram, it makes sense that that slope would be negative. So going back to the equation of our tangent, it's going to be y equals minus 3 over 4x, and that can be written as 4y equals minus 3x, or if you prefer 3x plus 4y equals 0.
Question 4 is a coordinate geometry of the circle question, and it's worth 25 marks. The circle C has equation x squared plus y squared minus cx plus 4y equals 12. Find the centre and the radius of C. Now in this question here, the only issue is that it also talks about the centre point as being C, which can get a little bit confusing, and the fact that C is the constant in our equation as well. So just to be aware of that, but it shouldn't affect us too badly. So first thing I'm going to do is I'm going to rearrange the equation of the circle that we've been given, and I'm going to do this by bringing the constant back over to the left, so by taking away a 12 from both sides. Once I have that done, I can use what I have from page 19 of my log tables. So this is called the general equation, so plus 2gx plus 2fy plus c equals 0. I can use that now to find the values of g, f and c. So here 2g is equal to minus 6, so g is equal to minus 3. Here 2f is equal to 4, so g is equal to 2. And here we have c equals negative 12. So we've been asked to find the centre. So the centre again, as per page 19, gives us minus g minus f. Sorry, I've written g instead of f here. So I end up with 3 minus 2. And based on the diagram, the fact it's in quadrant 4, that should make sense. Then we work with the radius. So this is a calculation. So the calculation is g squared, so minus 3 squared, plus f squared, so 2 squared, minus, now be careful with this one, it's minus c, and c is already a negative 12, so it's minus minus. When that's put into your calculator, we're able to get an answer of 5. The point P minus 1, 1 and the point Q both lie on C. That means circle C. Show that the line PQ is the diameter of C. So probably the easiest way to do this is simply show that the length of PQ is equal to twice the radius. So we're going to just use our distance formula from page 18, or length formula. And to do this, I'm just going to label my points. So we have x1, y1, x2, y2. The length of PQ is equal to x2 minus x1 squared plus y2 minus y1 squared, just so you know what we're filling into. So that's going to be 7 minus minus 1, so that becomes a plus 1, plus y2, so that's minus 5, minus 1 squared. Here we can go straight to the calculator. Make sure you're using your brackets when you're squaring, and we get that's equal to 10, which is equal to 2 times the radius, because the radius was 5. Therefore, PQ is a diameter. Now, there are a few other ways that you could have worked this. I think this method is probably the most straightforward, but I'm going to talk you through some other options we have to do this. So I have 4 more options, and all are based off the same logic, but they have a different calculation to show it. So option 2 is basically showing that C, the center point, is on the line PQ. Now, I'm going to show you 4 different ways we can do that. So the first, most obvious, is find the equation of PQ. That involves finding the slope and then the equation, and then subbing in C and to check if it's on that line. If C, the center, is on that line, then this is a special chord called the diameter. The second option, again, still checking that that center point C is on the line PQ, is to check to see if the slope of PC is equal to the slope of CQ. If they are the same slope, then that must be a continuous straight line, i.e. P, C, and Q are what we call collinear. So they exist on the same line, and again, once C is on that line, then PQ must be a diameter. The third option for proving or showing that the center point is on the line PQ is to get the area of the triangle PCQ and showing that that's equal to 0. Again, another way to show that the 3 points are what we call collinear. And the final method that we could use to show it is by finding the equation of PQ, like we did in option 2A, but then using the perpendicular distance formula at the top of page 19 to find the distance between point C and the line PQ. When that's 0, we'll know that C is on that line PQ. Again, these are all other methods to show that PQ is the diameter of that circle. The point R lies on the positive y-axis and the angle P or Q is equal to 90 degrees. Show that the coordinates of R are 0, 2. So first thing I'm going to do is I'm going to use my diagram to sketch out what they're talking about. And there's the triangle they're talking about, making this the point R. Now, they haven't told us in the question that R is on the circle, but this is only a sketch. It doesn't matter as long as you've put it on the positive y-axis to work out using our first method. The second method I'll talk through, and that's a little bit different. So what I know is that angle there is 90 degrees, and I know that the point OR is on the positive y-axis, which means the x-coordinate is 0. So I'm going to keep OR as 0y. So the method I'm going to use first is showing, or rather using the fact that POR is perpendicular to ORQ to figure out this point. So I'm going to work with P, which is minus 1, 1, and OR, which is 0, y, and I'm going to get the slopes. I'm going to label x1, y1, x2, y2. My slope is going to be y2 minus y1 over x2 minus x1. Be careful with your signs there. It's minus minus, which makes it a plus. So this simplifies to simply y minus 1. So then we're going to work with ORQ, so 0y, and Q is 7 minus 5. And there's x1, y1, x2, y2. And the slope is y2 minus y1 over x2 minus x1, which is minus 5 minus y over 7. Now, because they're perpendicular, the slopes are opposite reciprocals. So one is equal to the negative, or we change the sign and flip the other. Now, an easier way to work it is slope. So M1 is perpendicular to M2. This means that when I multiply them together, I get negative 1. And that's probably a little bit easier to work with in an algebraic way. So I have y minus 1 multiplied by, now remember that's kind of over 1, so lay it out so that your numerator, the top line, is in line with any numbers on their own, like that y minus 1, and then I have minus 5 minus y all over 7, and that equals negative 1. So I have a little bit more space here to work this out. We can multiply across by 7, so let's multiply across by 7 to get rid of that denominator. If you kind of struggle, you might want to put, if you struggle with fractions, you might want to combine them first. So we get y minus 1 by minus 5 minus y is equal to minus 7. So we do y times minus 5 minus y minus 1 times minus 5 minus y. That equals minus 7 minus 5y minus y squared plus 5 plus y equals negative 7. Minus y squared at minus 4y, tidying that up. I'm going to add a 7 to both sides as well. So I get plus 12 equals 0. And I'm going to make it a positive quadratic by changing all of its signs. So then when we get to here, we need to either use guide number or whatever way you factorize it, or you can use your minus b formula if you prefer. So I'm going to just use trial and error here, which is a version in guide number. You get y plus 6, minus 2. And then our two answers are y equals negative 6 and y equals 2. The valid answer is y equals 2 because y is positive. And they told us that at the start, that it was on the positive y-axis. So therefore, OR is 0, 2, which is what they asked, QED. So that's the first method or first option to work out or show that OR is 0, 2. The second option is more of a geometric way. So again, I'm going to draw this out. And now I'm a bit more confident with my drawing and the fact that OR is on the circle, because the triangle PRQ is a right angle triangle with a diameter as the hypotenuse. So OR must sit on the circle in order for that to be true. And this is coming from Theorem 19, or rather the corollaries from Theorem 19, which is each angle in a semicircle is a right angle. So I'm going to use the fact that OR is on the circle, and I'm going to take the equation, and I know again that OR is this point 0, y, and I know that this is on C. So I'm going to sub it in. So I get, instead of my x, I'm putting in 0, and instead of y, well, I'm leaving it as y. So I get 0 squared plus y squared minus 6 times 0 plus 4y minus 12 equals 0. And when I tidy that up, I get y squared plus 4y minus 12 equals 0, which is actually the same quadratic trinomial we had using the last option. So we basically end up with the same thing. So we get y plus 6, y minus 2 equals 0. My two answers, y equals negative 6, y equals 2. This is not valid because y must be positive. So y equals 2. Therefore, or is 0, 2, which is what we were asked. The second point we've actually worked out is this one here. So that's where we're getting that negative 6, because this point here is 0, negative 6. So you can see that option 2 is a lot shorter, and it takes a lot less work to get that quadratic. The first option has a lot more algebra to it. However, I think option 1 probably will be more, I suppose, probably be easier to come up with that option. If you were very familiar with your theorems, they do make this question much easier.